Hello everyone and welcome to my Java tutorial series. In this particular episode I'm going to be going over variables again for the last time. We will be covering various math aspects of variables and some casting stuff. If you don't know what casting is, you will learn in this tutorial. So, onwards and upwards. Now, I have a couple numbers. Actually, I need to change this. Anyway, okay, so I've got two variables here. Both of them are ints. I will explain why they are ints. They actually are ints for a reason. I didn't just write them down, but I'll explain why later. But we have number 1 and number 2. So I want to add them together, or multiply them, or divide them, or something like that. I want to do math to them, right? So if you're just like sitting down and you're trying to figure it out for yourself, you would try something similar to this, perhaps. So, you know, number 1, number 2, done. Semicolon, because I know there has to be a semicolon. And it's giving me an error on the plus sign, but not the variables. So, something's working, but then something's not working. So what is the problem? You know, we've done everything right, technically. That is how you would normally write it, but we don't have a variable to store the answer in. Because what we're doing is we're just adding 50 and 5, and then what? We're just adding them. And the compiler's just like, okay, you're adding them, but I need stored in something. I'm like, well, what do you want me to do with this number, 55? What do you want me to do with 55? Just toss it out? Because then why are you even doing this line at all? You know. So we have to put it in something. So I'm going to make another variable, int result. I'm not going to initialize it, and then I'm going to set result equal to this. Now, if you wanted to, if you really wanted to, you could do this. Whoops. But usually that's a little clunky looking, and you don't want to be you usually want to initialize all your variables at the top, and you're normally not just going to be adding random numbers. You're going to be getting these numbers from another input, which you're not going to be doing at the very top. So while you could do it this way, it's not usually recommended to do it that way. So just keep that in mind, that is a thing that is possible. Result, and then paste semicolon. So the answer of this equation would be 55, as expected. If we subtracted, we would get 45. And if we did this, we had 50 here, and we had 5 here, we would actually get negative 45, because it would be 5 minus 45, which would give us a negative number. So you do need to make sure that you do put the numbers in the right order. So just keep that in mind. Now, we could do multiplication by using the asterisk symbol, which is the symbol above the 8. Or a / for division. Again, it doesn't matter which number you have first, because we have 50 divided by 5, or we could have 5 divided by 50. Different answers, so keep that in mind. It's like normal math, you know, it's normal math. Computers are, because math has rules and logic, it's very easy to just put the math that every day, you know, people use into a computer, and computers can actually do math much better than people, obviously. That's why we have calculators. So there's really no difference in programming. You just have to know the symbols to put. Now, aside from your normal symbols, like your plus, minus, multiplication, and division, you also have a new one that is a modulus symbol, which is not actually ever used really in real life. Basically, what this percent sign, or modulus, will do is division, but it won't give us the quotient, which is, you know, the answer to a division problem. Normally, if we did division on this, it would be 50 divided by 5, which would be 10. But if we do the modulus, the answer is actually 0. Now, that probably doesn't make any sense, but what the modulus does is give you the remainder. So the remainder of this problem, there is 0. There is no remainder, because 5 divides wholly into 50. And if we did 50 divided by 2, even though we would get a completely different quotient, which would be 25, we would still get 0 for the modulus because the remainder is still 0. Now if we did 7, if we did 50 divided by 7, so if we did this, like for the modulus, we would get 1 for the remainder because 7 times 7 is 49, which plus 1 is 50. The remainder, the leftover amount, is 1. Now, while technically, internally, it's calculating like, a bunch of decimals and stuff, it'll figure out like the remainder for it. It really won't even pay attention to all the decimals and stuff it might get. I don't even know if it really calculates them with this. It'll just say, okay, 7 times 7, 49, we're almost to 50, and it just counts up until, it gets to 50, and then that's the remainder. So it's sort of like third grade division, where you're doing the division, but then you don't deal with decimals. You're just dealing with like the remainder of the number that you get, because decimals were a little complicated to introduce. Maybe not third grade, maybe a lower grade than that. I'm not entirely sure what grade it is that they started doing the different divisions. But anyway, it's not relevant. So that's the modulus. Basically, that's pretty much it for the different math operators and doing stuff on them. The one other thing I do want to mention is the order of operations. The order of operations in Java is the exact same as real life. Plus and minus are not done first, basically, that kind of thing. So if we had something like number 1, let's see, number 1, number 2, number 1, number 2. Let's just put a bunch of those down here. So if I did like plus, and then I stuck a multiply, and I did a division, and then maybe, I don't know, a minus, and another minus. This is a long, drawn-out number in series of calculations, not number, but series of calculations. But essentially, the way that this would calculate is, in like real life, would be the multiplication and division first, so it would be number 1 times number 1, and then it would be that number divided by number 2, and then it would go back through and do addition. So it would have it would be doing number 1 minus number 2, and then whatever this equation is minus that. Well, actually, no, it would just be from left to right, so it would be that minus number 1, then minus number 2. But the modulus symbol, that has to fit in somewhere because it's a new thing. We don't know where it fits in. But it fits in with the multiplication and division. It's on the same sort of level there. So we would start here. It would do num1 modulus num2. So that would give us 1 plus, or actually wouldn't do the plus, I'm sorry. So this would be 1, and then this would be 50 times 50, which would be like, I guess, 5,000. No, that sounds like way too much. 5 times 5, no, it'd be 2,000. I don't know, I can't do math, I'm tired. Anyway, but you get the picture. It'd be this, And if we added parentheses or something, if we did something like this, that would be sure to get done first. If we did like this, so it would ensure that this gets done before any other operations. So we can add parentheses in there to make sure that things get done first. I recommend always just adding parentheses, even if you don't technically need them, and you just write it out long like this, because it helps the user just sort of see how things are working. Especially, even in normal just algebra, you want to put things in parentheses so that they're easier to see and it makes sense, and you can kind of figure out what's going on. But anyway, that's the order of operations. Pretty much the same. The other thing is you want to be very careful whenever you're doing math. For instance, if I did, let's see, let's change this to just 5, and we can do this as 2, so this is an easier, this makes more sense. So result equals number 1 divided by number 2. Now, what do you suppose that this would give us? What do you think that would be end result? Now keep in mind we're working with ints, so we can't actually have a double. The answer to this equation would be 2. That would be the answer. Technically it's 2.5, but it would just give us 2. So you want to be very careful whenever you're working with integer values, because it doesn't like care about what's in the decimal part of the number. I don't even think it really even calculates it. It just works with whole numbers and that's it. So even if it's like 2.9 or 9.9 or something that's like really close to the next number, it's not going to round. So while technically if it was 2.5, it would round to 3, it would just give us 2. The answer, it just truncates the decimal part, doesn't even pay it any attention, and it doesn't round. So that's one thing that you need to keep in mind whenever you're doing calculations, is that you have to worry about whether or not you'll actually need to get decimal numbers or not. Because, you know, maybe we don't really care. We just want to get some number. But, you know, if you're doing a lot of calculations, you want to kind of keep in mind whether or not you're going to have that one circumstance where you'll get a decimal number, and because you have a 50-50 shot of really whether or not the number gets rounded up or down, of whether it should be rounded up or down. And the only problem is when you have that one point where it should be rounded up and it's not. So if you want to take that 50-50 gamble, that's fine. Or, you know, you can just use doubles. But if you're using doubles all the time, you're using like twice the memory that you could be using if you were just even using just ints, let alone something, you know, like a byte or a short. So you really don't want to just use doubles for every single number that you have. That's why they made multiple kinds. So what we can do is we can just make a couple of these numbers doubles, and we don't have to make all of them doubles. So for instance, we would have to have the result be a double because we would want to be storing a decimal. And then if we make actually we don't even have to make either one of these doubles either. We can just make the result a double. And then what we can do is we can do what's called casting. Now casting is basically telling a variable that I want you to behave like another kind of variable temporarily. Just this one line in this one instance of code, I want you to behave like another variable. So I could do this. I could do double, and then what's going to happen is it's going to actually give me 2.5. Now I can't show it because we haven't learned how to do any sort of output, but I would get 2.5 from this because it's treating this number 1 like it's 5.0, and then the way Java works is if a double, or a decimal really, is present in the calculation, it will return a number with a double, with a decimal. Of course, if I were passing this to an end, it would just truncate the 0.5 part, and it would just take 2. So as long as we have one of these numbers as a double, this will behave correctly. Now, the one thing that you need to keep in mind that you don't do by mistake is this. Because what this is doing is it's still casting, but it's going to do, okay, so this is in parentheses, okay, do this first, and then number 1 divided by number 2, okay, that's 2, and then make that a doubled 2.0, and you would get 2.0 as the result. Because technically, both of these are still ints when they're inside of this parentheses. But the answer, what this is saying is if you think of it like multiplication, you're multiplying the answer by just the double variable type. So you're turning the answer into a double variable type. You're not actually turning any one of these numbers into a double. So it does the calculation as if they were both ints because they are still ints. So that's one thing you have to be careful about, is that you don't accidentally do that, because it looks nicer when you do that, but you don't want to do that. Now we could actually perform a cast and do this for any variable at all. The reason I actually made all of these variables ints whenever I was doing this stuff is because if I make them bytes, and if I go back in here and let's make this a byte 2, and let's not actually make this a double, you're going to see that I'm going to get an error. And the thing says to add a cast to byte. So if I do this, it works. Now the reason I have to do a cast whenever I'm doing math, and this is why I did ints, because I didn't have to deal with this, but numbers that are lower than ints, because I believe a short would also do this. Let me check. If I take that out, I don't need you. Yeah, let me check and see if shorts will do this too. So turn all of these into shorts. Yes. Okay. So basically, anything that's less than an int, for whatever reason, it may be a compiler thing, it may not. I'm not entirely sure, but Java doesn't like it if you just add or subtract or multiply or divide or modulus them. Just doing that. You can do it fine, but you have to cast it, because I don't know if it has to do with the way that it stores the variables, and that you could potentially, heavy quotes there, potentially insert a number that is larger than what the variable can hold, or if it may actually just be that whenever Java is doing mathematics, it converts everything to ints anyway. I'm not entirely sure, but regardless, you will have to cast this if you're doing anything other than ints as the answers. It's no big deal. All you have to do is just byte, and then it's just saying that the answer of these numbers is going to be a byte. That's just what you're saying. So in this particular case, what we would be doing is, this may be like, could be 126, and we could add 2 to it, and technically that's too large for a byte to hold, because it can only hold to a maximum of 127. 126 plus 2 would be 128. It can't hold that. And so, it would give an error. But in this case, we're just kind of assuming, we're basically sort of signing an agreement with the cast, that we're saying that, yes, I know the risk, but I know that this is going to be a byte and that it's going to work. So it's okay. And even though, we can see the numbers that are in here, and we know, but it's just kind of a compiler thing. I would imagine that is what the problem. I'm not 100% sure on that, but that is my theory on why it makes you do this. You would have to do this for shorts as well, but that is no problem. But this can be rather useful, other than just the thing with the doubles and integers. This can be rather useful in certain circumstances where you want to force, like say you're getting input from a player. Well, it would have the same error that we had earlier, because it could say, well, the player could enter any number they want to, but maybe we trust the player, and so we want to say, yes, I know this is going to be at least this value, so it's okay. Force it to be a certain kind of, we can force it to treat it as a certain value. And of course, it will crash the program if I did, somehow get a number that was larger than 127 doing this. So that's one thing you do have to be aware of. Whenever you are casting, it's sort of forcing it to be a variable that technically it otherwise might not be. So the answer of this, okay, let's actually just do this. If I ran this, I don't know. I don't know if it crashed or not. Can't really tell. Basically, well, let me do this. Okay. It's not seeming to crash. But I mean, we would be adding more than this. The result would be able to hold. But since this is the last line, I don't think it's really making that big of a difference. So anyway, hopefully that makes sense with casting. You can do that to really any number and whatnot. Now, one thing to keep in mind is that if you have a byte and you're adding an int or something, you don't really have to worry about like casting bytes, ints, or shorts with each other, because if you have a number that is like, let's see, a byte, a short, and an int will all fit inside of a long, because the long is the largest kind of integer type variable out there. So you don't have to worry about casting like in a problem, to make sure that the answer is going to be in a long, because even if you set it to be in a byte and you're storing it in a long, it doesn't matter, because a byte's value of 120 between -128 and 127 can fit in a long. So they'll all automatically cast for each other. So if this were an int, I don't even need this casting here. It would just do the 2 byte things, and then sure, an int is different from a byte, but because a byte can be stored in an int, it doesn't really matter. And the same concept can be applied to a float and a double. They can also have that thing that apply to them because they're of the same type. So that's basically casting. Now, one other thing I wanted to discuss was some of the math sort of operators that can be done. Because if you do something like math dot, and then you can scroll down, you can see lots of kinds of things. We have, if you just kind of scroll over these, you can see each one has like documentation about what it is. So for instance, this one is the e, the value of e. This one is the value of pi. So if I did this, math.pi, semicolon, I could actually store this value. So I could just have a byte that is pi. Or actually it would have to be a double. So double pi equals math.pi. And there we go. So we have pi stored. And basically what we're doing, I'm not going to explain it in too detail, but what we're doing is we're accessing like a class or a set of pre-done code in the Java libraries, which is one reason why we needed the JDK, so we could have access to this stuff. So we're accessing the math class, which has all kinds of things that allow you to do a bunch of math stuff like absolute values. It will do powers and stuff. So you don't have to write all of that stuff. Someone else wrote all that code that you can just use by doing the capital math. You do capital M math dot and then whatever you want. So this will make more sense once I've actually gotten to talking about classes and methods and how they all work. But for the moment, for instance, we have ABS, which is absolute, and we can do, it returns the absolute value of a double value. It has to be a double. But if we did this, we could just we could pass it a number. We could just do like 4.0 semicolon. Or we could actually have a variable in here. We could do result, which we could make a double, and then it would be fine, which result doesn't have a number. So let's just stick this down here. There we go. So we're passing it the result of this equation. So basically, you can do whatever you wish. If you just read a little bit, you can see there is a power thing. You got logarithms. Let's see. Sine, cosine, tangents, powers in here somewhere. Rounding. Where is power? don't see power. Kind of wanted to show that one. There, pow. So, but what this does is you have to actually give it two values. And if you read this, it should make sense of how to do this. I kind of wanted to try as much as possible to not show something unless it has already been learned. But since I'm already talking about all the math stuff, I kind of wanted to show the math class to people so that they would know that that's there, even though I know we haven't talked about how classes work. But basically, you'll need to pass this two numbers. The first number is basically the first number is sort of like the number that you want the power raised to. I'm sorry, the number that you want the like raised, and then the second number is the power to raise it to. Because it says here, if the second argument is 1.0, then the result is the same as the first argument. So the second argument is the one that you would set the power to. So you would set the power to, like, 2. And if I wanted to, I don't know, raise 2 to the second power, that would be 4. So I would just put, actually, let's do that. We can do double power. Math dot pow would be 2.0, 2.0. The answer would be 4. So now if I did 3.0, it would be 8, 4.0 would be 16, 5.0, 32, and so on and so on and so on, with the powers of 2. So I'm pretty sure first number is that's how it would work. But anyway, that's sort of the math class and how that all works. Basically, just do capital M math and dot, and you can get whatever you want. So that hopefully will conclude everything that I needed to discuss about variables. I do believe I covered everything. If there are any questions, feel free to ask them. I will try to answer. And I will see you all in another tutorial. Bye-bye.